The Mininet tool that we've been using in the course is actually an example of network virtualization. We are in fact running an entire virtual network on your laptop. When you start Mininet using the mn script, each host in the virtual network is a bash process with its own network namespace. A network namespace is kind of like a virtual machine, except it's a lot more lightweight. It's in fact called OS-level virtualization. So each one of these virtual nodes has its own view of the network stack, as shown here with these interfaces, but it has a shared file system, and it's not in fact running its own independent virtual machine. The root namespace manages the communication between these distinct virtual nodes, as well as the switch that connects these nodes in the topology that you set up. Virtual Ethernet pairs are assigned to namespaces. For example, S1 is assigned to an interface in H2's network namespace, and S1 ETH2 is assigned to a network namespace in H3's virtual network namespace. The OpenFlow switch effectively performs forwarding between the interfaces in the root namespace, but because the interfaces are paired, we get the illusion of sending traffic between H2 and H3. When we make modifications to the OpenFlow switch via the controller, we're in fact doing that in the root namespace. In summary, virtual networks facilitate flexible, agile deployment by enabling rapid innovation at the pace of software, vendor independence, and scale. We talked about the distinction between SDNs and virtual networks, as well as various technologies that enable virtual networks, such as virtual machines for creating virtual nodes and tunneling for creating virtual links.